Hopefully it don't sound like a broken record up here, and I'll do my best to explain it in my own words. So here for my starter project, I made the light sensing little robot. The main principle on which it works are these two photoresistors up here in the front. And a photoresistor is a resistor whose resistance decreases in high light, and then when it's dark, their resistance increases by a lot. So if I turn it on here, you'll see the lights flash, the motor spin, and then there's also a slow mode, back in fast mode. If I cover this, that light goes off, and then that motor stops spinning, and then when it gets light again, it starts up. And then put on the background, well, there's not a whole lot of friction, but if there was, it would move around. The only issue is that this is kind of an error on the part of the manufacturer, is that one motor is a bit stronger than the other, so it tends to turn a bit. But it works. That's covered. That and that go off. That's covered. That and that go off. And then both are covered. Stops. So that is the light sensing microbug. And for my main project, I built the miniature wind turbine, like Andy. So how it works is I spin it, or the wind's supposed to spin it, but here I'll spin it, and then a bunch of magic happens and the LEDs light up. So let's go through and explain a bit. So up here we have the 3 vertical sails. I cut the sails myself from aluminum. That was one of the most frustrating parts for me, because for the sails, it was basically like, just try and figure out how big you think they need to be, and just cut them out, and then stick them in, see if they work, and if they don't, do it again. And that was super, super frustrating. And then for a couple days in a row, like at the end of the day, I'd kind of be sneaking away and throwing away like 10 sails, and then like I'd look at the roll of aluminum and be like, do I have enough to make 3 sails at work? Is this going to be a problem? But eventually I got that to work. So sails are held in place. There's these 2 plastic sail holders with little slots cut into them. That there's these 2 tabs for each sail on each end here that they slot into, and then it was really difficult to put the sails in correctly, especially because a lot of the time the sails weren't cut super well because of my poor cutting skills. And then those are held up by these 2 shaft collars, the sail holders are. And then I found that a lot of time when I spun it, the aluminum rod down the middle would spin, but the sail holders just kind of rotated around it. They didn't really spin in tandem with it totally. So then I used epoxy putty. You can see here and here. I used epoxy putty to just make it more secure, so that when it spins, when the rod spins, or the sails spin, the rod spins, blah blah blah, they all spin together. So then we'll go further down here. This is the base of it all. There's a lot of little mechanical parts. There's some more shaft collars, some washers and whatnot. These are the 2 plastic discs that make up the bulk of the base. So all the plastics here, the sail holders, the 2 base discs, and the 2 gears, they were all laser cut, but there's a bit of an issue with the 2 discs because there's a lot of holes in the discs to slide the rod through. These hex standoffs go through, and then the motor's attached to. But when it was laser cut, all the holes didn't exactly cut all the way through. So it had these little outlines of holes, but then I had to go back myself and actually hand drill the holes, and then just file them out so that anything would actually fit through them. So that was a little frustrating, but got to use the drill a bit. So yeah, 3 hex standoffs, some 1/4-20 screws, lock washer, flat washer to hold them all together. And then the rod here is connected to a gear which meshes well with this gear here, which connects to the motor. The motor is also epoxy to the gear to make it spin more correctly. It was a bit difficult because there's not much space down there, so putting the epoxy on was a bit tough. And then when the motor is spun, the energy goes through, comes out as electrical energy, and connects to this circuit here. And believe it or not, this is actually the 4th time I built this circuit, because originally I built it on a breadboard, and then I wanted to modify the circuit a bit. So I built a modified circuit on the breadboard, and then later I went, and this is a perf board. It's it does the same thing as a breadboard, but it's a bit different. I'll explain that. So then this is the original circuit that I made on the breadboard. I made again here, and then this is the fourth one. This is the modified circuit on the perf board. So a breadboard is basically you plug things in certain places. There's connections that you can make, and it's simple and it's good for making prototype circuits. And then a perf board is a lot more customizable because there's basically all these holes in it, and you put things in and you solder it, and really you can make any connection from one point to another as long as you can solder it there or connect it through a wire, which makes it more customizable but more permanent and more difficult and time consuming to make the circuit. So you want to have a good idea of what you're doing before you go to the perf board. So the modification I made to the original circuit is, you can see here, on this one there's only one LED, and then on my modified circuit there's actually 3 LEDs, and in this circuit the LEDs are actually replacing 2 diodes, so a bit of a difference. Oh, there we go, there's a bit of a difference. So what the diodes are doing, there's 8 diodes on the circuit. Fun fact, LED stands for light emitting diode. So I figured, why don't I just take out a couple of the diodes from the regular circuit, plug in some LEDs, and then have some more light come off of it. And then the interesting thing is, because what the LEDs, or excuse me, what the diodes are doing is they're actually converting alternating current from the motor to direct current to reach the end LED. So on the modified circuit, these 2 LEDs are actually getting alternating current, and this one, the very last one, is getting direct current. So you can see when it spins, they all light up, but then when it starts to fade out, these 2 guys will kind of flash as they dimmer out, and this guy will just have a smooth fade. And the only issue I've had with the modified circuit is that these 2 LEDs take out a bit more energy than a regular diode does. So you have to, it needs more power to get to the final LED. But otherwise, it's a very fun modification to make. I think it's pretty cool. Yeah, and that's basically it. So if there's any questions.
What else do you attach besides LEDs to that?
I mean, you can power basically anything from it, as long as you get enough power. So there's probably not a whole lot of applications with something that puts out such a small amount of power, but really the possibilities are endless in the bigger scale of like using wind power, converting to electrical, and then using electrical energy to power stuff.
Did you ever measure how much power it creates under different situations?
No, that's not going to hear.
What's your next step?
My next step, so I've basically been working on it up until today. Actually, I just finished, so soldering these 2 circuits, it took me 2 days each to solder each circuit, which was very tedious, I have to admit. So I actually just finished soldering this one this morning, and I gotta say, I built the circuit 4 times, and probably the happiest moments here was every time I plugged these 4 wires in and then spun it, and the LEDs actually lighted up. I was like, thank Jesus, you know, because I don't want to have to go back and try and find where I made the error. That was another problem with, or another difficult thing about the perf board, is that like, any connection you want to make, you have to solder it like that. So I'd be looking at this and just staring, like, did I make that connection, did I make that connection, or like, crap, did I solder those 2 things together, you know, so. But in terms of next step, since I just finished that, I'm kind of thinking, I think checking the power output would be something really cool. But then in the grander scheme, I think wind energy is very interesting. So I might look for other stuff in that area. Anything else?
Are you getting, like, at the LEDs, are you getting AC or DC?
So in the regular circuit, we have 4 diodes here. They're making a diode bridge, which is acting as a full wave rectifier, which essentially changes alternating current to direct current. So again, 4 diodes here, AC coming in, DC coming out. This LED gets DC, has a, I don't know if you can see because the capacitors, but this LED smooth glow, and then in my modified circuit, I've removed 2 of the diodes, which are at the beginning of the circuit, these 2 kinda. So in this circuit, those are LEDs, so because it's not yet converted to DC, these 2 LEDs are getting AC, this one's getting DC. And that is why, at the end, they will flash out, because that's what alternating current does when plugged into LEDs. So these 2 AC, this one DC.
Did you have resistors in front of those LEDs which get blinked on AC?
No.
So are they robust enough so that, because it's like the AC will be like 12 volts or something from the generator?
Well, I mean, it works. My thought process is LED stands for light emitting diodes. These guys here are diodes. So if I plug a light emitting diode, it just diode plus light. But I did have to try a couple of different sizes of diodes, and I found that what would happen was when I had bigger diodes, this guy at the end just wasn't getting enough power. So yeah, I mean, I think they're actually taking more energy out of the circuit overall than the regular diodes do.
So let's say you put your wind turbine and it's really, really windy outside, right? If it's too windy, would the LEDs burn out?
If you're in a tornado, maybe. Yeah, I suppose so. I suppose it's certainly possible, but the way it is right now, it actually, Andy mentions we took them out, and it was kind of windy that day, and it spun like a little bit, but it didn't really get going. So it does need a lot of wind to get going in the first place, but certainly if I was in some hurricane or a situation like that, the LEDs would probably burn out, yeah. Anything else? Great, thank you all very much.